computer, right? Fine. The next topic what we'll be discussing is software. So basically here we'll be concentrating on system software. So you know that there are two types of software. One is called as application software. The other one is called as system software. So the application softwares are the ones which we use in our day-to-day life. Okay, like any application you can take, like you may be running a game, that is application. Okay, or any apps that you are running on your mobile phones. All these are applications. Okay, so, there are if you are using a calculator, that is an application. Okay, if you are using MS Paint, that is an application. So all these are examples for application. So application software comes at the top layer. Okay, after the application layer, there is the application layer. The application software comes at the top layer of the operating system. After that, there is another type of software which is called a system software. The system softwares, or we can say that system software is a high privileged software which can directly communicate with the hardware. System softwares are high privileged software which can directly communicate with the hardware. So if you remember the typical diagram of how the operating system things works. So at the lowest level we have hardware. Okay, the next level what we have is system software. Operating system is also an system software. Okay, so here we have system software, the next level, because system software can directly access the hardware. And in the next level what you have is application software. The application software, it cannot directly access the hardware. If it wants some job which which requires the involvement of the hardware, then the application software will just place a request to the system software, and through the help of the system software, it will get the job done. Okay, and these are the typical tasks a system software will do: receiving and it's not interrupting, interpreting. Okay, receiving and interpreting user commands. Okay, so for example, if you are typing something in the keyboard, say you are using a Linux command prompt and you are giving some commands, then there should be some software which receives that command and it interprets and it performs some operation. Okay, so that is done by the system software. That is one of the tasks done by the system software. Similarly, it manages the secondary storage devices, like storing data into the secondary storage device, or retrieving data from the secondary storage devices, controlling IO units, reading and writing, reading from IO unit and writing to IO unit, translating source program to object form. So when you write any high level language program, before execution it should be converted into object code. That will be done by a special system software which is called as compiler. The compiler is also an example for a system software which converts source code to object code. And also there are files for linking and loading. So all these are also examples for system softwares. So these are the typical tasks of a system software, right? Okay. So one of the primary system software is operating system. So, operating system, we have already learned the course operating system. So you know the typical tasks of operating system is assigning memory to a process, assigning the disk spaces, moving data from memory to secondary storage devices, or from secondary storage devices to the memory, or from memory to IO device, or from IO device to memory, and handling input output operations. So these are the primary tasks of an operating system. That is, operating system is basically a resource manager which manages the resources like processor, memory, IO devices, secondary storage devices, etc. Okay. So let us discuss uh, discuss how a typical operating system works with an example. Okay. So let us take a simple case. Let us not make things complicated. Let us try to understand the functions of an operating system with a simple case. So let us consider a system with only one processor, one disk, and one printer. Okay, this is a simple case. So there is a computer with only one processor, one disk, one hard disk, and one printer. Okay, and say there is an application program which is already compiled and it is stored in the disk. This program is already compiled into object code and it is stored in the disk. Now we want to execute this program. So if we want to execute the program, first what should be done, that particular program, which is the object code of that program, should be transferred from the hard disk to the memory. Okay. So once you transfer the program, once you transfer that object code from the hard disk to the memory, then it will start executing. Okay. Say this particular application program, which is currently executing, it wants to read a data file. It wants to read a data file from the disk. Okay. So, okay, the application program, whichever you are executing, that program wants to read a data file from the disk. Okay. After reading the data file, so what will happen, that data file is available in the disk. So again, that data file should be brought into the memory. The data file should be brought into the memory. So after reading the data file, this particular application want to perform some computations on that file, whichever it is received. Okay, it want to perform some computation on the data available in that particular file. Okay, after performing the computation, it would like to print the result in the printer. It want to print the result in the printer. Okay. So this is a typical example we are going to discuss how the operating system is going to do this particular task. Okay. So this is the problem definition. I think it's clear. So there is an application program which is already compiled to object code and is stored in the disk. Now the user wants to execute the program. So the object code is moved from the hard disk to the memory and it's started getting executing. During execution, the program which is getting executed would like to read a data file from the disk. Okay. And after reading the data file, it want to perform some computation on the data that is available in that file which is recently read, and the result should be printed in the printer. Okay, so this tasks where the system program is involved and where the application program is involved, that we'll be discussing. Okay, so this diagram clearly explains the sequence of events that are happening. So these are the things which are involved. So there is a program which represents the application program, which is in the object format. Okay, the application program which is in the object format. And next, there will be some OS routines. We may not use the entire operating system. Some operating system routines will be used. Then there is disk, that is the hard disk. Then there is the a printer. So these are the units which is involved here, functional units which are involved. So initially the user wants to execute the program. Okay. So but the program is in the hard disk. So the application program cannot directly access the hard disk because it's an application program. It cannot directly access the hard disk. So it will place a request to the operating system's appropriate routine that so and so program should be executed. Okay. Now the operating system is loading the program. You can see here the first step is to load the program. So who is loading? Operating system is loading the program from the disk to the main memory. So that is what is being done during this time T0 to T1. This is the initialization period. So here you can see there is some gap here. So this is the initialization period during which this program is requesting the OS routine to load that particular file from hard disk to the memory. Okay. So during this duration, it is getting loaded. Okay. And again, there is some time gap because it should be properly loaded into the memory and some memory location should be allocated. Uh, every like process control block, all these things should be done, right? So it is loaded. So during time T0 to T1, the operating system loads the file from the disk. During T1 to T2, this application program is executing. It is performing some operation. Initially, it is doing something, let us assume. Then again you see at T2, this what that application program want to do, it want to read a data file from the disk. Okay, again it cannot read the data file directly from this disk because it's application program, it cannot access the hardware. So this application program at time t2, it is placing a request to the operating system that it is placing a request to the appropriate routine of the operating system that I want to read so and so data file from the disk to the main memory. Okay, so now again the operating system reads that particular data file from the disk to the memory. Okay, so that is happening during the time t2 to t3. OS reads the data file from the disk during this time. Okay, right? So again, after reading the data file, the application program performs some computation. So that is happening between T3 to T4. The user program performs computation. So after computation, it got some result. Now it want to print the result to the printer. Again, printer is a hardware, so the application program cannot access the printer directly. So once again, the application program or the user program is placing a request to the hard disk that this is the result I got, which I want to get printed in the printer. So again, the appropriate routine in the operating system performs this job on behalf of the application program. It gets the result and it prints in the printer. So the printing is happening between T4 to T5. The OS prints the computed result to the printer. So that is OS will just write the data to the buffer, print buffer or the buffer register. Then the printer will print at its own speed. Okay? So this is how the application program and the user program communicates. So all the operations or all the tasks will not be carried by the application program. Only few tasks will be done by the application program, and wherever the hardware, the accessing the hardware is required for that, the application program will take the appropriate help of the it will take the help of the appropriate OS routine. Okay, and some places there may be some concurrent execution may happen. Say for example, here consider this time T4 to T5. During this time, actually there is no involvement of processor, because at T4 the CPU, the user program is requesting the operating system to write the result to printer, and the operating system is doing that. Operating system is writing the data to the buffer and printer is going to print. So during this time the processor is free. Okay, so now the processor, what it can do, while the job is getting printed, while the result is getting printed, operating system may load next program or the next program into memory during this time. Processor may load the next program into memory during this time. Okay, similarly if you see this time T0 to T1, T0 to T1, during this time it is loading, the operating system is loading the, what you call, operating system is loading that program. So during this time, if there is a previous, during this time printer is free, so if there is a previous print operation is pending, then the processor can perform this print operation. Are you getting? So during this time the next program can be loaded. Similarly, during this time, the print of the previous job can be done. So like that, uh, multiple jobs can be done at the same time wherever possible if the processor is free. So during T4 to T5, OS can load the next program. Okay, because operating system just writes the content to the print buffer, then printer will be printing. So during that time, it can do that. Similarly, during T0 to T1, the operating system can print the previous result while loading the, uh, that is print the previous result in the means operating system is not printing. It is only writing to the buffer of the printer. Printer will print, and during the time it is getting printed, it can load the current program or the next program. Okay, so this type of executing multiple tasks or overlapping uh, two or more tasks is called as concurrent execution. Okay, this concurrent execution is also called as multi-programming or multitasking. Fine. So let us stop here for this session. So in this session, we have discussed about bus structures and the system softwares. Okay, thank you.